Okay, our topic for today is decimals. Now, decimals don't really have a good, um, straightforward definition to describe them, but the key to understanding decimals is in the name, deci, right? In fact, the number system that we use is the decimal system, even for whole numbers. Right, we've talked about how counting, we go 1, 2, 3, 4, 5, 6, 7, 8, 9. And for each of those, we have a unique symbol. But then once we get past that, we reuse the 1, but instead of just writing a 1, we put a 0 after it to show that I don't have any more 1s. I now have one of this kind of unit. When we're measuring length, let's say 1 inch, 2 inches, 3 inches, 4 inches, 5 inches, 6 inches, 7 inches, 8 inches, 9 inches, 10 inches, 11 inches. And then instead of saying 12 inches, we say 1 in the foot place and 0 inches. And then 1 foot, 1 inch, 1 foot, 2 inches, and so on. Right? We go by dozens of inches before we move on to the next unit. So that number sense, even here, we still write 1, 0 because we don't have a different symbol for 10 and 11. Historically, different civilizations did have different ways of representing these quantities. We've talked about Roman numerals before. The Indo-Arabic numerals that we use were based on this 10 system. And even the Roman numerals and other systems were often based on 5 and 10, but not everything was. So this basing on 10, where we have 10 tens, moves over to a new place. Now we go ones, tens, hundreds. That's something we're very familiar with. We've been using that. We've been using that all semester with whole numbers. But what if instead of getting 10 times bigger each time as we go left, we think of it as getting 10 times smaller as we go right? If I have 100 divided by 10, that moves me from the hundreds place down to the tenths place. Right? So if I gave you the long division problem, 6,000 divided by 10, I hope you're not doing actual long division. 10 goes into 6, now 10 goes into 66 times. 10 times 6 is 60. Now the decimal point's over here, so I have no remainder, but the 6 is in the hundreds place, so I have to bring these zeros up to show that the 6 is in the hundreds. That's kind of a lot of work. That's a bit of a waste of time here. What we really want to do is just say, I've moved from the thousands 10 spots less, now I'm in the hundreds. It's not that the decimal point really is moving, it's that this number is shifting to the right. If I have 6,000, and I put my decimal point there, when I divide by 10, this is getting 10 times smaller, so it's moving to here. But if you're not using fancy pens where you can click and drag your number around, it's a lot easier to leave all of this writing alone and just shift this dot over a little bit, where we move from this spot. Relative to our number, the decimal point is moving left. Right? If the number moves right, that's the same as the decimal point moving left. But the decimal point is still separating the ones digit from the tenths of a 1 digit, which is here. So now instead of this being in the thousands, it's in the hundreds. Instead of this 0 being counting hundreds, now it's counting tens. 100 divided by 10 is 10. This 0 was in the tens spot. 10 divided by 10 is 1. This 0 was in the 1 spot. 1 divided by 10 is 1 divided by 10. So if I start with a new number, instead of 6,000, do 6,437. Put my decimal point in. If I divide that by 10, that moves 6,437 over by one spot. So now instead of the thousands, 1,000 divided by 10 is 100. So I have 600. 400 divided by 10 is 40. So that 4 is in the tens spot. I did have 6,437, right? There's our expanded form here. So now I have 640. 3 is in the 1 spot, so that's 3 ones. And that 7 ones is now being divided by 10. So that 7 is being divided by 10. 643 and 7/10. And it's the same if I divide by 100 or divide by 1,000 and so on, right? If I look at my place value, we know we have ones and tens and hundreds and thousands place and so on, 10,000s. As I divide by 10, 1,000 divided by 10 is 100, 100 divided by 10 is 10, 10 divided by 10 is 1, 1 divided by 10, 1 divided by 10. A tenth divided by 10, right? Remember with our division, dividing by 10 means multiplying by a tenth. It's getting 10 times smaller. So you already got 10 times smaller. A tenth of a tenth is a hundredth. And then a thousandth, and then 10,000ths, and so on. So we have to be careful as we say this out loud. This is the thousandths, and this is the thousands, right? No th when it's an actual thousand. So seeing this relationship between decimal points and units lets us see how all of the rules about how the operations work remain exactly the same. So if I have, I'll just switch colors here, 6,437.829. The units here are 6,000s, 400s, 3 tens, 7 ones, 8 tenths, 2 hundredths, 9 thousandths. So I can write that in sort of semi-expanded form. Converting this into their fractions. But it's kind of annoying to have 3 separate fractions. Right, it's a 9 here. And so let's think back to some of the other numbers we've used here. When I wrote something like this, I could call that 1,400. Running out of space here. Let me make my pen a little skinnier. Or I can lump this 14 together and call it 14 not 14,000, 1400. Right? I'm looking at these two digits together to tell me my magnitude, and then the place of the 4 is the hundreds place, so it's 1400. Right? Those two word descriptions are both talking about the same number. Well, we can do the same thing over here. So you can show that mathematically. To get a common denominator here, 1,000 is a multiple of 100. 1,000 is a multiple of 10. So I have 800 thousandths plus, I wrote 20 hundredths. I'm not sure why I did that. It should be 2 hundredths. Hopefully you caught that mistake. Okay, 8 tenths, 2 hundredths, 9 thousandths. So that's 800 thousandths, 2 times 10, 20 thousandths, and 9 thousandths. In other words, if I use thousandths as my unit, 800 plus 20 plus 9, that's just expanded form, 829 thousandths. And there's our mixed number. Now, this might seem like a lot of extra work here. Let me just pick a new one. But when I say 43.075, it's kind of treating this like a phone number or a Dewey Decimal System library code number. Right? I'm not really thinking of it as a magnitude when I say 0.075. Technically, the official name for this number is its mixed number format. It's 43 and 0.75, that's 75, tenths, hundredths, thousandths. So I would say 43 and, meaning plus, right? For a mixed number, you say the whole number and the fraction part. 43 and 75 thousandths. Now in this class, we don't say things out loud very often. You're each working on your own. But when you do say it out loud, that's technically the way to pronounce this number. It also helps us see how to add, subtract, multiply, and divide decimals. It's based off of the same idea we've had for a while now, to add, subtract, or compare values. Remember how that finishes? They must have the same units. So our rules for adding, subtracting, and comparing decimals will require that those decimals have the same units. And to change units, multiply by 1. Or another way to remember that is that multiplication changes units. Right? We've already seen that just in this video. To change this from thousands to hundreds, what did I do? I multiplied. Right? It's a division symbol, but really I'm multiplying by 1/10. If I wanted to change 600 to 6,000, I would multiply by 10. We're changing the value by multiplying. If we want the value to not change, if we just want the units to change, we're going to multiply by 1.